You think the solar system has an edge, and Voyager 1 reached it like a finish line. That sounds true because we use simple words, left, outside, interstellar, like space has borders you can draw. But Voyager's data doesn't behave like a border story. It behaves like a trap for your intuition. At one point, Voyager crossed a region people call a wall of fire, with temperatures so high they sound deadly, yet the spacecraft stayed fine. Years later, it started sending wrong orientation data, while still pointing its antenna at Earth like it knew exactly what it was doing. So what is the edge supposed to be if heat doesn't burn and the probe can lie while still working? The answer is uncomfortable. Edge is not one place. It depends on what you decide to measure. And if you pick the wrong meaning, you will misunderstand the whole mission. If you want the full breakdown, subscribe to support the channel, like the video, and stay for the full lecture. Now let's rebuild the idea of the solar system's edge from what Voyager can actually measure, not from what the words make you picture. When you hear that Voyager 1 reached the edge of the solar system, you picture a real border. You imagine a clear moment. One side is inside, the other side is outside. That feels obvious, because almost every boundary you know is built from solid things. Shorelines, walls, country lines on a map. Your mind uses that same idea for space. But the solar system is not a box. It is not even one thing. It is planets, dust, gravity, magnetic fields, and streams of particles, all fading at different rates. So one word, edge, cannot point to one place unless we choose what we mean first. If we mean where planets stop, the edge is near the last planet. If we mean where the sun's particles lose control, the edge is somewhere else. If we mean where the sun's gravity no longer matters, that is farther still. Each choice can be measured, but each gives a different answer. So the simple logic is this. If one object can cross the edge in more than one way, then the edge was never a single line. It was a shortcut in our language, not a fact in space. You do not experience space directly. You build a picture of it using habits from daily life. When something changes, your brain tries to draw a line around that change because lines are useful. They help you decide what is safe, what belongs together, and what is separate. That is why people disagree about Voyager 1. Some say it left the solar system in 2012. Others say it has not left because it has not reached the Oort cloud. Both feel reasonable because each person is using a different shortcut for the word edge. One person means the bubble of the sun's wind. Another person means the farthest region of the sun's objects. Agreement also does not prove anything here. Many people can repeat the same simple story and still be wrong because the story is built to sound clear, not to match what is measured. Reality does not care which picture feels neat. It only follows the real changes in particles, fields, and gravity, even when those changes do not form a clean border. To talk clearly about the edge, we have to stop using it like a picture and start using it like a test. Physics does not ask, did Voyager leave? It asks, which measurable influence changed? Voyager 1 cannot see a border. It measures its environment, charged particles, the speed and pressure of the solar wind, the density of plasma around it, and the strength and direction of magnetic fields. If those readings shift in a lasting way, we can say it moved from one region to another. So one useful definition is the Heliopause. It is the place where the outward push of the sun's solar wind is balanced by the push of interstellar space. When Voyager 1 crossed that boundary in 2012, the data showed it was no longer swimming mainly in the sun's particle flow. This can feel unsatisfying because it does not give you a hard line you can imagine. It also removes some questions. Where is the edge exactly? Becomes which edge do we mean? Language like inside and outside fails because the change is not a sharp wall. The clarity we gain is simple. An edge is a rule we choose, then measure. A better way to picture the solar system's outer reach is not a wall, but a bubble. The sun blows a constant stream of particles called the solar wind. That wind makes a huge bubble around the planets called the Heliosphere. The edge in this model is the Heliopause, like the thin skin of a soap bubble. This analogy works because it explains why the boundary can move. The solar wind is not steady. When the sun is more active, the bubble can expand. When it is calmer, the bubble can shrink. The bubble also moves through the galaxy, so the front side gets more pressure than the backside, like air pushing against a moving car. But the analogy can mislead if you think the skin is solid. It is not. It is a region where conditions change, particle types, pressure, and magnetic behavior. That is why people call it a wall, but it is not a hard surface. This structure matters because it replaces the wrong question, where is the line? With the right one, what changes when you cross from the sun's flow to interstellar flow? Voyager's job is to measure that change, not to hit a border. Near the Heliopause, Voyager's instruments detected something that sounds impossible, extremely high temperatures, roughly 30,000 to 50,000 Kelvin, often described as about 54,000 to 90,000 degrees Fahrenheit. People hear that and imagine the spacecraft flying into fire. The problem is that we treat temperature like it means how hot the space around you feels. In everyday life, that works because air is dense. Many particles hit you each second, so heat transfers quickly. Out there, the particles can carry a lot of energy, so the temperature number is high. But the particles are also very spread out. Collisions are rare. So even if single particles are energetic, not enough of them hit the spacecraft to deliver much heat. The reading tells you about particle energy, not about a burning environment like a furnace. This is why nothing is broken when we hear wall of fire. Intuition resists because we learned heat on Earth, where density is high. But the same physics stays consistent. High temperature plus low density can be safe. Voyager survives because hot is not the same as dangerous in thin space. Voyager's story feels one way. It leaves, it crosses, it never returns. That makes outward feel like a special direction. But the direction is not magic. It comes from uneven pressure and from history. The solar wind mostly flows outward because the sun is a strong source of particles and energy. Far away, that flow meets the interstellar wind, and the two pressures balance at the heliopause. If conditions were perfectly balanced everywhere, the boundary would not look like a one-way exit, but they are not. The sun changes, the local interstellar space changes, and the whole bubble moves through the galaxy, creating a front side and a tail. The laws of physics do not ban reversal. In principle, particles can go either way. What makes reversal unlikely is probability. Random motion plus large scale flows usually mixes and spreads things, not neatly sends them back. Your experience also forces a one-way feeling because of memory. We record Voyager's past, then wait over 20 hours for signals to arrive. Events cannot be undone in our records, so outward is not a rule of nature. It is what you see when gradients, motion, and history push one direction more often than the other. You want to talk about Voyager 1 as if it shares your present moment, but it does not. When Voyager sends a signal, it takes about 20 hours and 33 minutes to reach Earth. So when you hear Voyager is doing fine, you are hearing about an earlier Voyager. This breaks the idea that there is one universal now that both sides share. On Earth, we make decisions using old information. Then we send commands back, and those commands arrive more than 20 hours later. Even if Voyager changes state right after it transmits, we will not know until much later. There is no instant check. That also affects what it means to cross the edge. The crossing is not a single dramatic moment we watch live. It is a conclusion we build from delayed measurements that change over time. Different observers can slice the story differently and still be correct. One person can say the crossing happened at a certain date, based on one set of readings. Another can choose a different threshold and get a different date. What stays fixed is not our shared present. What stays fixed is the order of measurements Voyager recorded along its path. By the time Voyager 1 reached interstellar space, the edge story was already less clean than people wanted. Then, in May 2022, it became messier in a useful way. Engineers saw strange data coming from a key system called the AACS, which helps the spacecraft know it. Orientation, and keep its antenna pointed at Earth. The data suggested the spacecraft did not know how it was positioned, but the signal itself stayed steady. That meant the antenna still appeared to be aimed correctly. The spacecraft also kept receiving commands and sending other science data. It did not go into safe mode. So one channel was telling a story that did not match the rest. This is where several intuitions collapse at once. Data is not reality. It is a report produced by hardware in a harsh environment. Edge is not one line. It depends on what you measure. Broken is not a clear label when only one subsystem is confused. And now is not shared when every diagnosis arrives over 20 hours late. What replaces these intuitions is not a comforting conclusion. It is a method. Compare signals, define boundaries by tests, and accept that uncertainty is part of what Voyager finds. Confusion here is not noise. It is the cost of describing a place we cannot touch.